Yeah, so I'm going to very quickly introduce you to my research project and how we used Forge in this project. So I'm from the Technical University of Munich, and our research center is the Leonhard Urmeier Center. We are actually 5 chairs who focus on digital methods in the built environment. And we have, several industry partners that support and fund our research. So that's, of course, a part of the public funding we get. So that's very important for us. And we have several cooperations with, for example, Building Smart, but also government and federal institutes. So we are quite into digital methods. My research project focuses on automated progress monitoring. I know there are several applications for this in this domain. So what we are basically doing is we take pictures of construction sites based on several methods. So for example, with UAVs, but also with crane cameras, webcams, but we also tested manual methods. We generate a point cloud out of this and compare this to a 4D building information model. So we need a building information model that not only holds the 3D geometry, but also the 4th dimensions or time process schedule. We compare this, the point cloud of the as-built status and the as-planned status, and in an ideal case get all built elements that are available on the construction site. Then we can do a recalculation of our process plan and detect whether we have any delays or any deviations from our initial construction schedule. The project itself worked quite fine so far. So here you can see one of our projects we tested. We have a very nice point cloud out of it. So you can see the concrete in this from this building, very nice. On the other hand side, we have a 4D building information model. You can see something like that here. So we have modeled all elements, not only the elements itself, but also formwork and scaffolding and everything. Added the time to it, and as you can see here, we have a very nice, 4D model that holds the geometry, and additionally the time. As a result, we can see, we can select several time steps of our observation and see, okay, what did we detect, which elements were detected, and additionally we can also see which the elements and corresponding picture of these, so that you can always see what is the actual status on our construction site. So of course we can do the point cloud comparison, but in the end, if you want to compare that as a human, it's always nice to have a picture with the actual status out there, and that's a nice way to compare it. You can do a reprojection because we know the coordinates of our cameras where we took the picture from the photogrammetric methods, and then we can reproject our 3D geometry into this picture here. In the end, this can look, for example, that's the same view again, sorry. Okay, yeah. So in the end, you can see that you can see the overall progress. You can see which elements were delayed and which were built in time. And however, in the end, we thought, okay, we have these results, and we have a nice viewer that works on our desktop machines, and we can provide this. It's a C# application. We can provide that to all project partners. We can provide them with the tool and they can install it. However, we noticed that we have had several project partners that had no privileges on their machines, so they weren't allowed to install the application on their computers. Some had some issues with the libraries we required, so it's always quite of a hassle to get your application started. So we were thinking, okay, we definitely need something web-based because the browser is installed everywhere, so it would be quite nice to have an easy solution where everyone can access the results of our project, where we can also have it on a mobile device, and so basically that everyone can access the information without any hassles. And the most important part, of course, is that you can also visualize your building information model. And another important part for us as a university is that we have open standards supported so that we can also use IFC files for this visualization. And all of this works actually with Forge. So we built a nice application that you can see right here. That is a video capture from our browser. So you can see different time steps of the observation. You can filter your construction elements based on the detection status of the element. You can focus on elements, see all the semantic information for that. And yeah, that worked quite fine so far. And that's it from my side. Thank you very much.